Hello everyone. Welcome to SHR Trinity. If you're looking to build a career in artificial intelligence, generative AI, prompt engineering, or large language models, you're in the right place. In today's video, we're starting our prompt engineering interview series, specially designed for beginners, freshers, and professionals who want to prepare for prompt engineering and generative AI interviews. At SHR Trinity, we focus on practical, hands-on learning with industry-relevant technologies. Our 30-hour comprehensive generative AI training program covers everything from AI and machine learning fundamentals to prompt engineering, chatbot development, retrieval-augmented generation, agentic AI with Crew AI, Langflow workflows, MCP, and Llama Index integration. Every module is designed with hands-on practical sessions to help you build real-world AI applications and become industry-ready. Throughout this interview series, we'll cover 50 carefully selected interview questions, progressing from beginner to advanced level. We'll begin by understanding what prompt engineering is, why it's becoming one of the most valuable skills in the AI industry, its importance, career opportunities, future scope, and the benefits of learning it. As we progress, we'll explore different prompting techniques, prompt design strategies, prompt optimization, prompt debugging, real-world use cases, practical interview scenarios, and best practices used by AI professionals. Every interview question will include a clear explanation, a professional sample answer, common mistakes to avoid, practical examples, follow-up interview questions, and interview tips to help you build confidence and prepare effectively. Whether you're preparing for interviews at OpenAI, Google, Microsoft, Amazon, Meta, Anthropic, NVIDIA, Deloitte, Accenture, Infosys, TCS, Cognizant, Capgemini, or any organization adopting generative AI, this series will help you build a strong foundation in prompt engineering and prepare for real-world AI interviews. If you're interested in mastering generative AI through hands-on projects and industry-focused training, you can find details about our comprehensive generative AI training program in the description below. Now, let's begin with our first interview question. We are also excited to announce the Generative AI Comprehensive Hands-On Training Program by SHR Trinity. This is a 30-hour intensive course featuring 20 live sessions of 1.5 hours each, held Monday to Friday from 7:30 p.m. to 9 p.m. The curriculum covers Python, transformers, prompt engineering, RAG pipelines, autonomous Crew AI agents, Langflow workflows, and model context protocol. To enroll or learn more, contact us at contact@shrtrinity.io or call us at +91 70956 78789. We will now begin with the next 10 questions of our prompt engineering interview series, covering questions 1 to 10. Question 1. Since you are interviewing for a prompt engineering role, let's start with the basics. How do you distinguish between artificial intelligence, generative AI, and large language models to a non-technical stakeholder? I explain it as concentric circles. Artificial intelligence, AI, is the outermost circle. It's the broad science of making machines mimic human behaviors like reasoning and decision-making. Within AI lies machine learning and deep learning, and a specific subset of that is generative AI. Generative AI is focused purely on creating new, original content, like text, images, or audio, rather than just classifying existing data. Finally, large language models, LLMs, are a specific, text-focused subset of generative AI. They are trained on internet-scale text corpora to predict the next word in a sequence. So, while all LLMs are generative AI, and all generative AI is AI, they represent increasingly specialized technologies. Question 2. What exactly is a prompt, and how does the concept of prompt engineering differ from traditional software coding? A prompt is a natural language input provided to a generative AI model that directs it to produce a desired output. Traditional programming is deterministic. You write explicit rules, loops, and logic in languages like Python, and for a given input, the code executes exactly the same way every time. Prompt engineering, however, is probabilistic. We guide the model's weights and attention using natural language instruction. It requires structuring context, constraints, and instructions dynamically, predicting variations in model outputs, and iteratively refining text to achieve stable results. Question 3. Walk me through the standard components that make up a production-ready prompt. If a prompt fails, which component do you check first? A production-grade prompt consists of 4 core components. 1. Instruction, what the model should do. 2. Context, background info or reference data the model needs. 3. Input data, the specific payload to process. 4. Output indicator, the desired format or target style. If a prompt fails, I inspect the instruction first to ensure the action verb is explicit and unambiguous, followed by the constraints within the instruction to make sure they aren't conflicting. Question 4. How do tokens work in LLMs, and how does tokenization affect how we write prompts? Have you ever run into a situation where tokenization caused a model to fail? LLMs don't read words or characters, they process tokens, which are subword chunks, averaging 4 characters or 0.75 words per token in English. Tokenization can cause issues with spelling, reversing words, or math because characters are grouped together. For example, a model might struggle to count the letter P in strawberry, because straw and berry are represented as unified tokens. When writing prompts, I avoid asking the model to perform character-level operations directly, or I instruct it to split the word into hyphenated characters first to force individual token processing. Question 5. Explain the concept of zero-shot prompting and one-shot prompting. When would you choose one over the other? Zero-shot prompting is presenting a task to the model without any examples, relying purely on its pre-trained instructions, e.g., translate this to Telugu, hello. One-shot prompting provides exactly one example of the input and expected output before the target task, e.g., input, cat-output. Input, dog-output. I choose zero-shot for straightforward, common tasks like summarization. I choose one-shot when there is a specific formatting style, tone, or schema constraint that is easier to demonstrate than to explain in words. Question 6. What is role prompting, or persona prompting? Why does assigning a role to a model change its output quality? Role prompting involves instructing the model to act as a specific character or professional, e.g., act as a senior system architect. It changes output quality by conditioning the model's attention mechanism. In the high-dimensional probability space of the LLM, asking for an answer generally searches the entire internet text distribution. Specifying a role forces the model to prioritize vocabulary, styles, and concepts common to that specific profession, filtering out irrelevant casual language or lower-quality references. Question 7. If I want to generate a response in a very specific format, say a clean markdown table, how would you write a prompt to guarantee the output structure? To guarantee a markdown table output, I do 3 things. 1. Define the structure explicitly, state the column names and order. 2. Provide a schema template, show a visual mock-up of the markdown table headers and divider line. 3. Establish strict constraints, explicitly state, do not output any conversational introduction or conclusion. Output only the raw markdown table block. Question 8. How do you organize instructions and input data visually in a prompt? Why does this organization matter to the model's attention mechanism? I organize prompts by grouping system rules, context, and user input into clearly demarcated sections using standard delimiters like triple backticks, hashes, hashtag, or XML tags, e.g., context/context. This separation is vital because LLMs use self-attention to relate tokens. If instructions and raw input text are blended without clear boundaries, the model can suffer from attention drift or instruction leakage, where it treats the user's input data as new instructions, potentially causing errors or security issues. Question 9. If you ask a model to write a poem about prompt engineering, what temperature setting would you use, and why? For writing a poem, I would set a high temperature, typically between 0.7 and 0.9. Temperature controls the randomness of token selection. At 0, The model is deterministic, choosing only the absolute highest probability tokens, greedy decoding, which leads to repetitive, dry outputs. A higher temperature flattens the probability distribution, allowing the model to choose slightly less likely tokens, which introduces creative vocabulary, metaphor, and novel structures suitable for poetry. Question 10. What is the difference between system prompts or system instructions and user prompts? How do they interact during inference? System prompts set the persistent rules, guardrails, persona, and core constraints for the model's behavior. They are injected at a higher priority level in the API. User prompts are the specific dynamic inputs or tasks provided by the end user. During inference, they interact in a hierarchical manner. The model processes the system prompt as the global operational boundary, and then interprets the user prompt within those boundaries. This helps prevent user inputs from overriding safety rules set in the system instructions. Thank you for watching. If you found this video useful, please subscribe to SHR Trinity, click the like and share buttons, and stay tuned for the next part of this series. If you are interested in attending our live training sessions or have any inquiries, all our contact details are displayed right here on screen and are also available in the description below. Feel free to reach out to us. See you in the next video.